Hello everyone and welcome to the class of Emerging Trends in Microeconomics Research Econ 413, lecture number 11, Engels Curve and Demand Curve Derivation. So this lecture is basically based on our previous lecture where we used the Lagrangian method to basically derive the demand equation of Q1 and Q2. So let us start with this lecture. Before moving on to the derivation of the Engels curve, let us repeat what we have already learned from the Lagrangian method, but we will not be covering the entire method in detail, rather than discuss the major points so that it could be revised, or for people who are viewing this video for the first time, they will know what has already happened. So the Lagrangian, the utility maximization, we have u, a utility function which was function of q1 and q2, and we specified values for them as u is equal to q1 alpha and q2 1 minus alpha. And we want to maximize this utility subject to the constraint of y is equal to p1 q1 plus p2 q2. So what we do first is make a Lagrangian equation, and that is equal to q1 alpha q2 1 minus alpha plus lambda, and the constraint, and basically the value of the constraint must equal to 0. So y minus p1 q1 minus p2 q2. This is our Lagrange. The first order condition, that is with respect to q1, equals to alpha q1 q2 1 minus alpha, and this will be q1 alpha minus 1 plus lambda, and we have p1. So here is the negative sign, this will be negative, minus lambda p1, and this entire should equal to 0. Then the second first order condition with respect to q2, that is equal to 1 minus alpha into q1 alpha q2 1 minus alpha minus 1 and lambda p2, that is equal to 0. Finally, our third partial derivative, that will be equal to y minus p1 q1 minus p2 q2 is equal to 0. Now when we solve this using these three equations, and we solve it for q1 and q2, when we solve it for q1 and q2, what we got was equal to alpha y over price of the first good, and q2 is equal to 1 minus alpha into y over p2. So this is what we have already done, that's why I'm not going into the detail of the steps rather than what we got yesterday, and these results are important for us because based on these results, we are going to focus the angel curve and the demand curve. Now, basically, what is demand? Law of demand. Law of demand tells us that when price increase, quantity demand decrease, and when price decrease, quantity demand decreases, keeping other factors such as income, taste, and population, and all those factors keeping them constant. So here, when we increase the price, since price is in denominator, an increase in the denominator will decrease the overall value. Hence, Q1 will decrease. So this is, you can say, an evidence for. It is not an evidence because it is not a research question, but rather then a mathematical proof for the demand curve. And similarly for P2, when we increase P2, Q2 will decrease. And if we decrease P2, Q2 will increase. So this is basically demand for Q1, and this equation tells us demand for Q2, keeping the income constant in both cases when we keep the income constant. So this we can derive our demand curve from these two equations based on, or we can say that based on the concept of budget constraint and indifference curve, we can understand the demand curve. Similarly, there is another curve that is called Engel curve, and the Engel curve tells us the relationship between income and quantity. So when we increase the income, keeping the prices constant, when we increase the income, quantity will increase. But you can know from these two equations that income is common in both equations. Income is common in both equations. So when income increase, both Q1 and Q2, both of them will rise. And this can be shown through a curve, and that curve is called the Engel curve. So let us move into the detail of that curve and see how Engel curve is derived based on the budget constraint and the utility maximization. So let us start by deriving the demand curve. And what is the important ingredient for deriving the demand curve is the budget constraint and the indifference curve. So let me draw the budget constraint and the indifference curve. This is, we have again two goods, Q1 and Q2, and we have our initial budget constraint, and we have our initial indifference curve, and they meet at point, they they are tangent at point A. So an individual will consume at point A, and let's say that if the price increase, what will happen? And we have two options. We can either increase the price of Q1 or we can increase the price of Q2. So in this case, let us increase the price of Q1. When the price of Q1 increase, the curve will rotate backwards. Since the price increase, the ability of a consumer to consume is also declining, as purchasing power is declining. So the next equilibrium will be at point B. Then if further the prices are decreasing further, what will happen? We'll have another curve, further rotation, and we'll have a third indifference curve that is meeting at point C. Again, I'm very sorry for the response of the pen, some technological error. Anyhow, I hope you can understand the graph. So we have 3 points now. When we are increasing the price, the budget constraint is rotating backward. not shifting entirely but rotating, and at this point it will be fixed, it will be pivoted to the point at on the y-axis. So when we join all these points A, B and C, what we get is the price consumption curve. This curve is called price consumption curve. So let me draw that. If we combine all the points, a curve in this form will be made, and we call that price consumption curve. Again, the pen is not working properly. It's sometimes very irritating. Anyhow, this is the price um, consumption curve, but we still do not have our demand curve. So in order to derive the demand curve from this, let me make another graph below it. And here we have quantity Q1, but on the y-axis instead of Q2 now we will have the prices, because demand curve is basically the relationship between price and quantity. So this is P1 and Q1. Now at point A, at this point the prices were low, so we may call or choose this point PA where the prices were low initially, then the prices increased to PB, and then the prices increased to PC. And let us extend the quantity on those prices. When we have lower prices at PA, the quantity demand was, let's extend it at PA, quantity demand was Q1. So this was the quantity demand at this point. At PB, the quantity demand, we can extend this point up to here, and at PC, the quantity demand is even lower. We are consuming lesser and lesser. So this is Q1A, Q1B and Q1C. You can see already in the first graph that the quantity was decreasing. Here the quantity was decreasing, and similarly here we can see that the quantity from Q1A to Q1B and then to Q1C. So it is decreasing in both the cases. Now let us join all these points. When we join these points, what we get is a demand curve, and it is clear from this demand curve that there is a negative relationship. When price was higher at PC, the quantity demand was lower, and when price is lower, the quantity demand is higher. So this is how we derive the demand curve. And next we move on to the Engel curve and see how we can derive the Engel curve as well. So let us derive the Engel curve as well, and to do so we are again using the same technique. We have again the similar graph. This is Q1 on the x-axis, Q2 on the y-axis, and we have a budget constraint and in a difference curve. So initially we will be consuming at point A. Now what happens is that the income of the individual is increasing. So when his income is increasing, we move to higher budget constraint, and similarly higher indifference curve. So the new point will be point B. Then again, there is a further increase in the income, and we move to the third budget constraint and the third indifference curve, and we call that equilibrium point as point C. And so on. We can increase the income as much as we want, but this is sufficient for our understanding. We have shifted it twice, so it is sufficient to understand what we need to understand from here. Now, when we rise income, the consumption of both goods is increasing. Q1 and Q2, both goods are increasing. So, combining these points, point A, point B, point C, let's combine them. This is income consumption curve. Income consumption curve. Right? Again, sorry for the writing because of some technical issue with the pen. It's not taking the input. Anyhow, we can understand the basic concept that the income consumption curve is a curve that shows all the points on the budget constraint. As we are increasing the budget constraint, the points which a consumer will choose on those budget constraints and which can maximize their utility. So we can also check this relationship with the prices. In this case, we are not changing the price. If we change the price, the slope of the budget constraints will be changing. But you see, all of these budget constraints, they are parallel to each other, meaning that there is no change in the price. So, price will be the same. Y-axis for price, and this is Q1. This is our demand curve, dA. Then we have demand curve, dB, and demand curve, dC. Extending those quantities at the older price, we are consuming Q1, but since price is the same, we are shifting the demand curve. And remember the law of demand. In the law of demand, we say that it is a relationship between price and quantity, keeping all other factors constant. So when price changes, we will move along the demand curve. But anything other than the price, if that changes, for example, income changes, price of a substitute could change, taste of the consumer changes, or population changes, the result of them will be a shift in the demand curve. And here it is, the income is rising. So because of the rise in income, the demand curve is shifting. And on the same price level, we are consuming more and more goods. So how does this translates into an Engel curve? Engel curve is the relationship between income and quantities. So we can also graph that We could draw that below this, the second graph, but since the lack of space, let's draw it here. We have income Y and quantity Q1. When income was, let's say, YA, we were consuming QA. When income was YB, we were consuming QB. And we can extend this QA and QB line directly from this graph. This axis can be directly represented in this graph, but since there was lack of space, we are drawing it separately, but hope you understand what we are doing here. And YC, we are consuming QC. So you can understand it from here. Let me change the color of the pen so that you can separate it out. When income was low, consumption was low. When income was increasing, consumption was increasing. So combining all these points, when we combine all these points, we will get a curve, and we call this curve as Engels curve. So let me summarize these two curves. Demand curve is a relationship between price and quantity, whereas the Engels curve, it shows us the relationship between income and quantity. Now we know about the income consumption curve and about the Engels curve, but let us see how the income consumption curve slopes in different cases. So what about inferior goods? What we have done so far, both Q1 and Q2 were normal goods, but then there are some goods that are called inferior goods, and by definition inferior goods are those goods when income rises and their demand decreases. So those goods are called inferior goods. So let's see how our income consumption curve could shape in such situations. Let me draw the graph for Q1 and Q2 again. We have on x-axis good called Q1, and on y-axis we have the good called Q2. Now we have this typical budget constraint, and we have our indifference curve. At this point, the amount of Q2 we consume, we call that Q2A, and the amount of Q1 we consume, we call Q1A, and this equilibrium point, let us name it as point A. So point A is our equilibrium, and Q1A, quantity 1 consumed, and Q2A, quantity 2 consumed at this specific point. Let us have our let us extend these points, and these are just imaginary points that will help us in understanding the concept of inferior goods. So what if our income increases, and if our income increases, we move to a higher budget constraint, and that should be parallel to the initial budget constraint. Now we have three possibilities. We have made some sections. We have three possibilities. Either the new indifference curve, it will touch the budget constraint at point B. It can touch the budget constraint at point C, and it can touch the budget constraint at point D. If it touches at point B, our income consumption curve could shape like this, or it can move anywhere between, let's say, this area. Let me highlight it with yellow. This part of, sorry, yellow is not visible. Let me choose another color. It can cross the budget constraint at any of these points, any part of the green line. But when the income consumption curve is shaping uh, a bit differently, let's say our new difference curve is somewhere here, then we will move, our income consumption curve will move backward. It will have a negative slope and it will move backward. In this situation, when it moves backward, in this situation at point C, you can notice that after an increase in income, we have increased the consumption of Q2. But what we have done is we have decreased the consumption of Q1. The consumption of Q1 has declined, whereas the consumption of Q2 has increased. Means that an increase in income does not result in an increase in the consumption of Q1. So in this situation, this Q1, this is an inferior good, right? And there is another possibility, and that possibility is if income consumption curve slopes downward below this quadrant, uh, below this line, and it slopes downward. In that case, we are reducing the consumption of Q2. And when we reduce the consumption of Q2, then Q2 becomes an inferior good. In this situation, Q2 is inferior good. So by definition, an inferior good, when there is a rise in income, then we decrease the consumption of that good. What we summarize from this graph is that whenever we have, let's say, an initial, let me draw this quickly. We have Q1, Q2, and we have an initial budget constraint. We are consuming at point A. Then we have a new budget constraint, and we can extend a horizontal and vertical line from point A. If the new consumption lies above this area, then both the goods are normal goods. If it falls in this area, both the goods are normal goods. But if it falls in these quadrants, in this quadrant Q2 is inferior, and in this quadrant Q1 is inferior. So this is our key takeaway from the graph. Now there is another question. Uh, what if both Q1 and Q2 are inferior? If Q1 is inferior as well, Q2 is inferior as well. then how can we draw that graph? The answer to that is not possible, because for such type of analysis, at least one of the goods should be a normal good. For this graphical analysis to be valid, for this validity, at least one good should be normal. So that is important, and you should remember it. So thank you for watching this video. If you have any question, please do ask in the comment section. Hope you have understood this lecture, and we will try to expand this lecture in the next class. Thank you so much.